Alright guys, before I begin, last time we made a game video, we stopped here at the jump um, algorithm. Um, Here I want to talk about it a little bit before I go anywhere else, just to give you guys a caught up, just get the new people caught up. So instead of having this algorithm here, I'm just going to turn this into into a function. So here, let's just exit that. Not exit. I mean, cut that out. So the create function is to func for func in Swift. That's how you do it. Jump node. Let's just call it jump node. It's gonna take in a node of type sk sprite node, of course, and then it's gonna apply and pause to that sprite node. So whatever that node is, instead of player, it's gonna apply and pause to that. So replace where you see players with node, just like so. And about the jump leeway, I didn't talk about this last time, but this is more like an area where the player or the node can still jump. By setting this number small, it prevents the player from being within those number. You can see I'm checking when the velocity is between the leeway before I allow the player to jump again. And by setting this to 1, it prevents the player from being able to jump while in mid-air or while falling. So here in our jump, when we press the jump button, we want to do the jumping, of course. So here, let's call it the jump method, and let's pass in the player object here, and let's run our code just to test how that works. By setting this number low, it should prevent the player from jumping while in mid-air or while in mid-fall, just like so. No matter how many times I press this, it would not let the player jump unless the player is already at a standstill, like on the ground. So anyway, this video is not about this function, but more about collision detection. Collision detection uses something called bitwise operation. In Swift, we have something. Well, most game, there's two ways to detect collision, right? You can detect when for example, a player and an enemy object are close together, or when they actually make contact. And in Swift, we're concerned with the category bit mass, which is a number that represents our object, and the collision bit mass and the contact bit mass. In this case, by default, you're represented with this number, and this allows you to contact anything. But to get it to start detecting collision, we have to implement an interface, I believe. Let me open my other project here as reference. Open this in. I'll just open this and put this to the side. I have some method in this one. Okay. So here we have our scene class, right? And just like if you're familiar with Java, you implement a protocol. In Swift, you implement something called an interface. And to implement interface, you just put a comma before the class. So here you have a class name, and this class is a SK scene class, right? And anything you put after that comma would be the interface you're implementing. In this case, we want to implement the SK physics contact delegate. And when you implement an interface, you have to also implement its method. So if I run this right now, it would run, but it won't do anything with the contact. So here I gotta do to delegate to self. So in the move to view, we want to do this. Now this scene is the contact delegate detecting collision. because I said to self, this scene itself will look for this contact. And to implement collision to detect collision between different objects, what I'd like to do is I'd like to set up an enumeration that represent the different object I will have in my game. So I'm just going to copy the enumeration I created in my other game and paste it here, and we can edit it a little bit. So in your game you'll have something like ground, enemy, and first of all in our game we'll just do something simple, right? We'll have our player, our enemy, and our ground, right? And when you're assigning category bit mask, you have to start with 1 as your lowest, and the number before that would be double, and the next number would be, you can't have any number in between, it has to be double, so 8. So the bullet would be, in this case, this is a different category. I'll just call it collision cat for category. So this lets me know that for player is categorized as 1, enemy are 2, ground are 4, and bullet is 8. So these are the things that we are concerned with in our game, right? You want to add more, let's say maybe obstacles in your game, like buildings or whatever. Let's just call it buildings. You'll have to double this previous number, so that would be 16. You cannot assign it a number like 5 because it has to be double the previous number and it has to be unique. Alright, so now that we have that, let's implement collision detection. So because we implemented our interface, we have to also implement a method that checks for collision, right? So that method is called didBegin. And here I have a method that I created for the other games. In this case, let's say you have a player, right? Object. You would do it like this because you don't know what object the player is gonna contact. Is it the object player because you don't know which body the player will be. Is it body A, body B? You have to call it twice, right? So here I'm gonna call it this one player collision. Player collision, and you do like this. If there's another object you want to check, for example enemy collision, you would just repeat this and create the function. So for player, I'll just do this. Ignore this commented number here. This just allows you to check at the strength of the collision. Let's say if the player get hit by a bullet, for example, and you want to see if the bullet hit the player hard enough before you apply, I don't know, life deduction or whatever. That's what this stands for. In this case, I'm not gonna do that. I'm just gonna call this as soon as the contact is made. So, but because we don't have this method yet, let's create it. I'm gonna create it up here. I'm just gonna call it player collision and the representative of function. All right. So this function, what you want to do is you want to check the collision between objects, right, and the player. So in this case, I'll just call this let me see, this one we call it node A, node B. It's being passed in between. I'll call it player and object. They're both SK node, right? Boom. If the object is, I don't know, let's see, ground, for example. If you look at our game scene here, we name our ground just ground, right? So now we can check for that collision. If object that the player contact is called ground, we can do something. Let's say we can print something, for example, and player touch ground, right? in a collision, you'll have two objects. When an object touch each other with enough force, it create an impulse, like a bounce off each other, right? And that's what happened during a collision. So let's test this by jumping the player and having him touch the ground again. And if it works, you'll see it says player touch ground. Oh wait, we've got one thing. What we've got to do is set the player's collision and to that I'm just gonna create a function. Physics. It's not gonna take anything. I'm just gonna manipulate it. Well, yeah, it's not gonna take anything. I'm just gonna manipulate the player SKS node here. So here we're just gonna do. Oh, let me see here. Player. Give me a second. Send it load. Alright, so we have an object called player, right? So there's three things we're concerned with player. It's category, right? We want the player. Let me do this here. Collision cat. We want to change that. So let's see here. We want to read this for now. There's three things you want to concern yourself with. The category. What are you going to categorize the player as? Because you created an enumeration earlier called collision cat, we can assign a player to collision cat dot player the raw value, which is 1, or you can simply just assign the number 1 like this, but it's easier for me just to see what I did by assigning it like this, so I know that there's that way. If I change here, I can change the rest where it exists. I don't have to go to every line that the player exists and change it manually. This way I can change it in one location and it gets changed everywhere. And for the collision bit mass, this is this is you telling the player what object in the game can the player can't touch: enemy, ground, bullet, or building. If you want the player to be able to contact all of this stuff, you would just add those numbers together, or you can do an OR operation, which is the same thing as adding. So for example, just do dot. Let's see, I wanted to touch enemy, of course, right? And then the OR would be just that. Just add all these values together, which is also, I want to player to be able to touch the ground. Also want the player to be able to touch building. I'm not gonna let the player touch bullet because I don't want the player to get hurt by his own bullet, right? So I'm gonna do the same thing with its contact test bit mass. So now that the player physics has been set, we have the function for that. Let's call in view did load. So in the view load, we want to make sure we call that so that gets set up. So if you look at all the things that player can touch, that's the enemy, the ground, and the building. You add those numbers together, you see 2, 4, 16. Those numbers add together is 2, 4 plus 16. That's 22. So if you don't change this here, by default the player will be whatever it is here, right? So here we set it to be, it by default is that random number, so by that big number, right? We want it to be specific, so 1. If you don't set it here, you have to set it in here, but I like to keep consistent, so I'm just gonna set it here also, 1. And we established that the thing the player can touch add up to 22, right? Because the player can touch the enemy, the ground, and the building that add up to 22. So let's go here and make this 22. Oops. We don't worry about the field master. That's another thing. You can read more about it just by simply googling. Boom. And the cron. In our game scene, the cron is 4, but we want the cron to touch everything, right? So we don't have to set it. If we already set it up in here, we don't have to do it in here. So for the cron, we can assign its category match to 4, and the rest, what it can contact would be everything. So 8 plus 16 plus 2 plus 1 would be its collision bit mass and contact bit mass. So let's assign cron to 4. So we have cron, and let's do this 4. Don't worry about your field mass, that's something else. And everything else, excluding 4, would be 3. Let me see, 8 plus 16 is 24. 25, 26, 27. So it'd be 27. So the cron collision mass would be 27, and the contact mass would also be 27. And because of that, because the cron can contact anything in this game that we have, which is right now we have the possible different object we have is player, enemy, cron, bullet, and building. Right? That's all the different category of object we can have in our game. Because the cron is set to that, now the player can contact it. So if I run this app, I should be able to detect collision between player and ground. As you can see, when player touches ground here, it printed. I'm going to jump again just to see that again. You're going to see it touches the ground twice because of the impulse of the bouncing. And that's how you do collision detection in game. So let's say you have another. I'm going to use game again. I'm going to create the enemy. Excuse me. I'm not feeling well, so excuse my voice if it's raspy or whatever. So let's see, new. Let's just create a new object, and let's make sure we add alpha channel so we can remove certain things and make it transparent. For the enemy, I'm just going to do a simple square just for the sake of testing this game, right? And let's color the enemy. I'll give it a red, just to represent danger. Enemy, danger, okay. Boom, boom, and let's give it an eye. Right. Let's give it an eye. Let's make it a white eyeball. Let's make it simple. Just a simple enemy. And let's do another one right here. Just like that. And let's paint that white. And let's make this black one. And let's crop it. Boom. Let's just export to desktop, and then we'll move it to our asset folder in our project. I'll just call it enemy desktop, export it. Alright, now I can minimize this, go back to my project, click asset, and open our finder. In desktop, here you have our enemy. Let's move the enemy to our asset so we can use it in our game. Now let's go back to our game scene, right? Now we have an enemy. Let's add the enemy to the game. So to do that, what we want to do is, again, go to view, show library, and search enemy. That's the most recent thing we added as the enemy. Drag it to our game, and let's give it that. Boom. Alright, there's our enemy. We have a category for enemy, right? Our enemy in this case is 2, but we want our enemy to touch everything, right? To be able to, we want to be able to detect the collision of enemy with everything, right? So if enemy's category is 2, the thing you can contact would be 1 plus 4 plus 8 plus 16, right? So what is that? 16 plus 4 is 20, 28, 29. So it's 2 and 29. So let's go back to our game scene here. 2, let's keep this a physics. You can only assign a value if it has a physics. And let's do the category bit mask to 2 and 29 for the other two. And this is 0 because we're not going to use this. The field mask is something else. You can read more about it, but I'm not going to discuss this here because we don't need it. And let's give this object a name. Let's just call it enemy. Boom, right? In our game, we can we're not controlling enemies, so we don't have to like create an object like this and add it like we did here. We can just look for the collision. We don't want to have to add the ground if we don't want to, because we're not doing anything with that, you know. So if I remove ground, for example, because we only add things like this here if you want to control it or manipulate, do something with it, access it later. We're not going to access the ground or make the ground move or whatever, or shake. We can, but since I'm not doing that, I can remove this and remove this completely, and it would still be fine, and we would still be able to we would still be able to detect the collision between the player and the ground, because all this is doing is checking the collision between the player and the object name. So if I run this again, you can see that excuse me, you can see the collision between player and ground will still happen, like here. Boom, there you go. Alright. So let's alright, we're back to enemy, right? So we assign the enemy a category, right? 2 and a collision mass and contact mass 29. That allows the enemy to contact anything. So we create like collision between enemy and other stuff. Let's say you want to check the collision between enemy and other object. We would do the same thing we did for player. We would just go to our game scene class here, and did begin is the method that we implement, because that we implement as part of the SK physics contact delegate, right? By implementing this interface, we have to implement this method. This method here we have a collision called player collision, right, to detect collision between player and other object in the game, right? So if you want to detect collision between player and enemy, you would just simply look for the name of the enemy, like so. So we call our node enemy. So in this case, I'll say player enemy. So now if I let me do one more thing. I edit this here. Last time I did this, the player moved way too much. Let me lower this number to, I don't know, 5 for example, instead of 50. And let's run that. So now, because we set the category of player enemy, when the player touches the enemy, you can see you can see that it's been detected. Let's do one more thing also in our game. We don't want the player to be above this button. Let's change that to 1. It's a good practice to just go into your game scene, and the controls you have in the game should be hovering above your game scene itself, the object that's in the game, right? Just like your button here, here, and here, this should be all the same. So what I do is hold shift and press select all of them and set the Z position 1 more. Then the rest, which is the rest is 0, but set 1 more, just add it, make it a 1, make it a 1 higher, that way it shows above this. And that should do it. That's pretty much it for collision. If you want to do something to the node, for example, let's say if a player hit the enemy, you want the enemy to be destroyed, right? You simply go back into our player collision method, and in this case, the enemy is an object with a name enemy, right? So you would remove that. To destroy the enemy, you can simply remove it or make it explode forever, but in this case we'll just remove it. So we'll do object, because that's the object, that remove from parent, and that we get rid of the enemy object. if you want the player to be disappear when the player hit the enemy object, you would do player dot remove from parent. So let me show you how this works. So if the player hit the enemy will disappear. Boom. As you can see, the enemy disappear. Alright. Another thing I'd like to talk about is, let's say you want to check collision between enemy and other object, right? You remember in our did begin method, we have thing here for player if the contact, because we're not sure what body the contact object is it A or B, right? So because of that, we have to call it twice, right? We'll do the same thing for enemy basically. So I'll just copy this code and paste it for enemy and just call it enemy. And let's just call this enemy collision. Enemy collision, right? And now that we have this, we want to create the method for enemy. I'm just going to copy this and modify it here and just call it enemy collision. Enemy collision. Let's see. Alright, now we want to see what happened, right? So if you want to check what happened when enemy touches a player, you can do the same thing you did here for player collision. So now the object will be player. So if enemy touch player, let's just print enemy touch player. So that's how you check different collision between different objects in games. I'm gonna move the player to the enemy, and you see player touch enemy and enemy touch player. And that's all there is to it with collision detection in video games. Let me pause this.